Happy morning to you, pre-algebra. As always, it's a new week and a new Monday and a new joke. So, how does an octopus prepare for war? Well, it prepares for war by being well armed. Let's get it. You get it? Well armed. It's got lots of arms. Yeah, you got it. Alrighty. I am on page 405 in your textbook. You want to go there. Again, this is another tough subject, but it's going to continue on of what we already know. So the first thing I want to talk about is our group of numbers. What I'm going to be saying is a term. It's called sequence. And so we have this chart here, and it's a group of numbers, and we're calling it a sequence. So whenever we're given a sequence, we're trying to find now an equation. So we're looking at one of those equations that we've seen before, an algebraic equation. So it's going to look something like t equals something. It's going to have an n, and sometimes we might multiply the n, and sometimes we might add something. So it's going to be another algebraic equation is what we're doing. So the number set that we're looking at, our sequence, it's always going to be rational, or like we were determining last time, is it a function? And so all of these are functions. All of our number sets that will be given should be functions. I don't know if there's a question that will ask you to see if it is a function, but remember the idea of the function is that our x's are not repeated. So we are going to treat them all as functions. So here's what we're getting at. We're going to be finding something called the common difference, and that's what's really going to give us our equation. So we're given the set of numbers. Our sequence is 6, 7, 8, and 9. That is our sequence. So we have a couple other words to define first. First one is our term number. Our term number is where is it within our sequence. So 6 is our first term number, 7 is our second, 8 is our third, and 9 is our fourth. So that's all the term number means, is we're counting up what is it in the order. Alright, then we have our actual term. We have 6, 7, 8, and 9. So what we need to be finding is our common difference. Our common difference is finding the differences between our terms. So for example, we are adding by 1. So we increase by 1 every single time. So to go from 6 to 7 is by 1, 7 to 8 is by 1, 8 to 9 is by 1 as well. We also see that's the same thing up top. That should always be true because we're talking about the order of the numbers. So if the sequence were longer, if it continued on, what do you think the next one would be? Let's say if we were going to find the fifth, what do you think it would be? If you could take a wild guess. Alright, you're probably yelling 10, obviously, because we know that it's showing a trend of increasing by 1. And we can represent that in an equation, and here is how. So we have our common difference, and whatever our common difference means is that we are multiplying our term number by our common difference. So we'll multiply our term number by 1. Alright, so 1 times n is just 1, or n, excuse me, 1n. So we say it as n. So we have t equals n. Alright, so there we go, we've got that down. We're multiplying each one by 1. However, we need to start somewhere, so we need to add 6, because we need to start at the number 6 to complete our problem. So it is, or excuse me, 5. My bad. Because we have the difference of 6 and 1 is 5. Sorry about that. So we find our difference. And that's just called our difference. Our common difference is when we're talking about between terms, just on this bottom part. But our difference is between our term and our term number. Okay? So if this is now our new equation, whenever we plug in for n, we should get our answer. So for example, if I plug in the number 1, our term number, number 1, 1 plus 5 equals 6, and that's true down at the bottom. If I'm going to plug in 4, 4 plus 5 equals 9, and that's down at the bottom too. So that's all it's showing is our equation helps us figure out the numbers that continue on in our terms, or excuse me, in our sequence. Okay, let's do another example just to kind of stay on track. So here's our group of numbers. We have 4, 8, 12, and 16. They are our terms. So I put them in the chart here, and I've started to say that now our common difference, I'm going to say CD, is we add 4. So we're adding 4 to each one. Okay, so we know that when we're trying to find our term, we're going to have to multiply by 4. Whatever our common difference is, we multiply it by our term number, n. That's an n. So we have 4n. And what if we just multiply it, if we plug in 1, is it going to make our answer complete? That's right, yeah. If we just plug in the number 1, we would get 4. So we don't need to add anything. We don't need to add anything, so you don't need to write the plus 0. But I'm just showing you that we don't need to do that step. So here is our equation, t equals 4n. So remember, to find the 4n, we are looking at our common difference, whatever the number is, between our first two terms, and we multiply that by n, n meaning our term number. Sometimes you may have to find the difference, just like we did in our last problem. So let's just do a quick example. I'm looking now at the very bottom of the page, and I'm going to do 1b. 1b. So we are given 5, 10, 15, and 20. So just so I know, I'm not going to put it in the chart, but if you want to, that may be helpful for you. But for the sake of time, I can tell that our difference is going to be plus 5. So I know that we're dealing with t equals 5n. And since 5 is our first number, if I plug in 1, we get the answer of 5. So I don't need to add anything. It's plus 0 again. We don't need to add. Okay, please flip the page. We have another concept. Now it's going to be like, what if we need to find the 15th term? So here's our example. We're given a set of numbers, and they're saying find the 15th spot. What's the 15th term number going to be? So I put it in our chart, and you'll see that on your page. We have 7, 10, 13, and 16. So I know that we're dealing with 3. 3 is our common difference. So start our equation with t equals 3n. And if I plug in 1, we fall short. So if I plug in 1, I get an answer of 3. So we need to subtract it. So we need to find the difference between 3 and 7. So that would be plus 4. If I add 4, then I know that if I plug in 1, that our answer would be okay. So that would be our difference. So the steps that I took again, that would be plugging in our number. So our first number is 1. And if I do 3 times 1, I'm just left with 3. And I know that's not the answer because that's not what's seen here. So if I add 4, that would complete our answer. So by adding 4, if I'm going to solve this, I plug in 1 for our equation. So I now have 3 times 1 plus 4. 3 times 1 is 3, and then plus 4 is 7. So I know that's correct. So here is our equation, 3n plus 4. So now it's asking about the 15th term. So here's the quick thing is the number 15, does that go on the bottom, right here, or is that going up here? So it's asking what is the 15th number. So for example, this would be the 5th term number and going on. So this is what we're doing. 15 would be our n. So what we can do is plug it into our equation. So I'm going to do 3 times 15 plus 4. Because 15 would be at the top. If we were going to make our chart bigger, this would be 6, this would be 7, going on and on. So it's in our ends, right here, our term number, so we know that we can plug it in for n. So when I solve this out, I get 3 times 15, which is 45 plus 4, and I get t equals 49. And that is our final answer. So if we're going to extend our chart all the way that way, and we had the number 15 on top, the number 49 would be on the bottom. Okay, let me do one more example. Remember, I know this may seem like it's going fast. If you have a question, please raise your hand for help. I do not know what you are thinking. So here's our next sequence. We have 5, 8, 11, 14. What is our 20th term? So we're looking between the difference between 5 and 8 is 3. So I know that t is going to equal 3n. And if I plug in 1, I'm going to get an answer of 3. So then I do 5 minus 3, which is 2. So I need to add 2. And I'm just going to double check. So I'm going to plug in 2 just to be safe. So this is now, we have 3 times 2, which is 6, plus 2 is 8. So that is okay. So I know that this equation is okay to use to find our answer. So we're trying to find the 20th term. So we use our same equation that we just created. T equals 3, except in n we put in 20 plus 2. So 3 times 20 is 60 plus 2. T equals 62. Okay, and again, what that means is that up here, dot, 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 we're now at number 20 in our sequence, and at the bottom would be 62. Okay, so we're really just finding a trend. That's kind of what this math is about, is finding our common trend and finding an equation instead of building these really big charts. We're making life easier by making an equation to solve it. So that's where I'm going to leave it today. Again, if you have questions, raise your hand, ask for help. Work hard. We have 3 weeks. Is that right? 3 weeks until spring break. So work hard. You guys are doing really well. And as always, I will see you in real life.